when absolute value of u equals a is equivalent to u equals a or u equals negative a.
Okay. Now, thank goodness here, we as instructors, we translate this. Can you imagine if you went to a class where no translation was done for you? All you saw was that statement, and other statements coming up. And you have to translate yourself. And math is not the best thing to read. You got to read this statement. Can you imagine reading this statement yourself? And that was my issue in grad school. I didn't know how to read math. And I found out right quickly that those professors were not messing around. They said, Ramsey, here's the math textbook. Yeah, so what? Read it. Read it. I had never read math. And finally had to make some sense of it. So with what Billy just read to me, guys, it comes down to this. If A is a positive real number, and she gave me something about a U there, she said, Professor, it comes down to this. Absolute value of, they call it U. Mark it straight down for me. Equal to A is equivalent to, let me write it like this. U is equal to A, or U is equal to a negative A. I guarantee you know what they're talking about. You have an idea in your mind what absolute value is. Those kids across the street in the middle school, they have an idea. Guarantee you. I could walk across the street and ask them to take the absolute value of 2. I guarantee most of them over there would say 2. What's the absolute value of a negative 2? 2. But if I ask them to do this, and they're saying the same thing as those middle school kids are. This looks more sophisticated, more described as a definition here. Guys, does it make sense? Let's try it. Based on this, it comes down to, and I have some problems here to look at, guys. Find the real solutions, if any. I got the first one look like this. Absolute value of 3x subtract 1 is equal to 2. Now, what's that statement right above there tell me to do to solve that? Absolute value of 3x subtract 1 is equal to 2. And you'll say, Professor, it says do this. What does that mean to do in this case? Go for it.
Do 3x minus 1 equals 2 and 3x minus 1 equals 2.
Okay, 3x minus 1 could be equal to a 2, or?
Negative 2.
Absolutely. 3x minus 1 could be equal to a negative 2. That's what the statement says. That's what Billy just read for me. That's what the statement says. Now I can solve these. Easily done here, guys, real quickly. 3x is equal to what? 3 here. X is equal to 1. Down here, if I solve this one, this is 3x is equal, looks like a negative 1. And x is equal to a negative 1/3. And I'm finished. Is that true? I didn't make a mistake, did I? I'm going to replace this in a set. You have 1 and a negative 1/3. You say, Professor, really? Really? They give that strange looking statement to me that Billy read. Here's the statement. And we're actually doing a middle school problem? We are. But who on earth would think this is where it came from? This is like a definition for absolute value. Okay, that's done. Letter C, I think, guys, we're not going to work all these. We don't have the time to work all these. I brought some in. Let me try another one here. I'm going to try letter C. Absolute value, x squared plus x is equal to 12. Solve for x. Now, if I apply that definition or statement she read to us, it says the x squared plus x could be equal to, if I look at it correctly here, 12, or x squared plus x could be equal to a negative 12. There's the statement again. Just merely using the statement. Now this one, no, not too much harder. It's a quadratic. So I can move that 12 over to finish this up. No problem. I think it factors. X plus 4, x subtract 3. Now I split this up. I'm looking at negative 4. I'm doing this fairly quickly, so watch mistakes. And 3. No problem. On the other side, this becomes x squared plus x, looks like plus 12, is equal to 0. I don't think that one will factor. So what might you suggest to try to get 2 more zeros, 2 more answers for this? Can I apply the quadratic formula? Or complete the square? Now if I try the quadratic formula, something strange may happen. I'm going to have negative 1 plus minus square root 1 subtract 4 times 1 times 12 all over, I think it's the 2 down there. If I place my numbers in the quadratic formula correctly. Is that true? Looks like negative 1 plus minus. Guys, underneath that I think is 1 subtract, what is that, 48? Is that negative 47? All over what? 2. Is it true? Now, right about there in my directions, did I say find, did I say just solve, or how did I describe this? It says find the real solutions. I'd go further if I had not used the word real. Could I not actually on this one go further and introduce an I? Maybe a strange looking answer, but could I introduce an I? No, my direction said just consider what? The real, just these 2. So my answers for the real zeros, answers here, are negative 4 and positive 3. And you're finished. So that's the mere definition of what absolute value means. Now, I know there's another problem there we could work. It's the same process, guys. Same process to use this statement that Billy read to us. Now, though, part 2. Now, look at this. Sort of close this chapter 2 down. Inequalities. Greater than, less than, greater than or equal to, less than or equal to, with an absolute value. Now, I know I have the statements probably on the handout. I think before I ask a student to maybe read the statement, I'd like to show you where those statements came from. I'm going to do this. I'm going to sketch the V-shaped graph for an absolute value and ask the class a few questions here. Let's think about it. Guys, the V-shaped graph that we've seen before definitely looks something like this. Extend it like that. And the blue, we're going to say represents y is equal to absolute value x. Now I'd like to throw in something else on this graph. I'd like to place, try the red here, a horizontal line. I'm going to place my horizontal line up here for a reason. I'm going to get some input from you guys. And let's say the name for that horizontal line is, let's say I went up to maybe 2. Let's say this was 2 right here. And therefore the name of the line is, let's put f of x and g of x. I think this will be better. Let's call this one g of x is 2. F of x, I think it looks better like this, is equal to absolute value of x. Can anyone tell me the intersection points of that red with the blue? What do you think this point would be? What do you think this point would be in coordinates? I need an x and a y. For the intersection points of that blue absolute value with the red straight line. Tell me.
We need negative 2 and 2.
Hang on. I love that. Negative 2, 2.
And 2, 2.
Love it. Is that true, guys? Now here comes the inequalities. That they in your textbook I don't think shows you. I'm going to show you where those statements came from here. Now suppose on the side you were asked to discuss this. when its absolute value of x not equal to 2, less than 2. Can anyone tell me, based on some things we've already done in class with other graphs, what would you look at, since I have a graph in front of me, to answer that question? Absolute value of x, which is my blue graph. And in fact, since I use red here, is less than 2. What does that mean? Go for it, Shane.
When is the y value of f of x greater than that of g of x?
Well, less than 2.
Yeah.
Okay. I'd like that something else, even easier, that we have done right here in this class based on some graphs. In fact, you may have been quizzed on it. Since you have the graph staring at you, how can you easily answer this question? Yeah, it says, when is my blue graph, the absolute value, below, less than, the red graph too? That's it translated. When's the blue graph below the red graph? And guys, the blue graph is below the red graph. Please tell me, I'll shade in. Is this the part of the blue graph that's below 2? Below the red. Now, can anyone tell me the extent, the interval that this is happening? From left to right, that's happening when?
Negative 2.
-2 over the positive 2. Is that true, guys? Okay, so here we go. So x is right like this, -2 out to 2 for an interval notation. And there's the answer. Done. Now, before I leave it and get into those statements, also, everyone in class realizes when I say an interval notation, you're caught between -2 and a positive 2. You could also think, hold on, Professor, could you also express it like this? That x that you're looking for falls between -2 and positive 2. Are we saying the same thing? When I say -2 up to 2, is that the same thing? We're caught between -2 and positive 2. So you could write like this. I'm in an interval notation also. Now on the side, before I get to the handout, someone tell me, please, tell me, now, express that. If I can use my red. Everything's color coordinated. Translated, when is my blue graph, above the red one, or on it. There's an equals mark here, or on it. So guys, if I look at my sketch over here, the blue graph is above. Well, that's above. Here we go, let me try it. Go here. Looks like this part is above the red, and this part is above the red. I'm sure you guys would agree. Is that true? Now, can anyone tell me an interval notation? By the way, they threw in an equals mark, so it could be right on it. Now, can someone tell me an interval notation, when is that happening? Go for it.
From negative to
Wait, tell me again.
from the negative infinity
Negative infinity.
to negative 2 including,
Oh, I love that. Hang on, -2 bracket. Union,
and from 2 to infinity.
2 bracket, through infinity. That's the answer. Based on graphs. I don't understand why your textbook didn't do more with graphing. When's above, when's below. You got the thing answered. Now though, before I leave this one over here, we got this one out of the way. Another way to express this, negative infinity up to a -2. Anyone tell me another way to express it and tell someone you're saying the same thing, but you've expressed it a little differently. What's another way to express this to someone? What type of x's are you looking for? If you say negative infinity up to a -2, someone may not know what infinity means to begin with. Give me another way to express it. It's, thank you, x is less than or equal to, in this case, what? -2. Or, I'll put the word or here for the union. That's going to be another way to express bracket 2 through infinity. Or x is greater than or equal to what? 2. And there's your answers. Now that will set me up to get this handout for that last section done quickly. Okay? Now I'm going to ask a student to help me. On the handout, here we go. Since we do have the handout, Billy read the first one to me, and I did a few of those exercises. Can someone read hang on, see if I got both of them in here. Oh, I do have both of them in here. Wow, Ramsey. Okay, number 2. I need someone to read number 2 for us. Who would like to read number 2? A few little extra credit points, like 6 points. Who would like to read for 6 extra credit points? Oh, look at those hands. I saw one hand going up. Every hand in here should have gone up. If the instructor says they're giving 6 points just to read, you know I'm not going to do that. I just want to see how many hands would go up. I saw one guy going up real quickly. Okay, I do need a volunteer though. Number 2, who would like to volunteer? Go for it.
Solve each inequality, express the solution using interval notation. A is any positive real number and U is any non-negative.
Isabella, hang on a second. Now read what the first one says.
Absolute value of U is less than A is equivalent to negative A less than U less than A.
Hang on. Hang on before she reads the next one for us, guys. Is that much like what I was doing right here? In the example, she says absolute value U is less than A, professor. If I see something that looks like that, this one looks like that. This looks like that. And quickly, she says you can write like this. You're caught between, in my case, negative 2 and a positive 2. Now I have that statement there. If I need to use it, I can use it. Isabella, tell us what the next one is. The next one's a little more difficult though. Okay.
Absolute value of U is greater than A, which is equivalent to U less than negative A, or U greater than A.
U is less than negative A, got you? Or U is greater than what? A. Guys, please tell me, does that sort of look like what I was doing on this one? Look at the one I did here with my sketch. Does it sort of look like my conclusion? And this sort of look at this conclusion here on this example. Does that sort of look like, in general, like a definition that Isabella read for us? Does it look like this? Does it resemble that? So if I see that, now I know how to deal with it. But I have to accept those 2 statements that she read to us. And if I accept those 2 statements, and I know those 2 statements, then I can solve all these. Now, this is statement number 1, statement number 2. Now we'll try a few of these guys with the handout. These are not hard, for goodness sakes. First one says, now solve absolute value 2x plus 5 is less than 7. Bring your handout. She just read to us. You think it looks like this definition? I'm calling it definition. This one or this one? Which one should I use? There's 2. There were 2 here. It's the top one. I see a less than symbol, and that thing has a less than symbol. So she says, Professor, if you see that, automatically rewrite it like that. And can someone tell me in this little application, what's that look like based on this?
Negative 7.
-7, less than
Absolute.
2x plus 5, no extra value. Less than what? Oh, here it is. I wrote it out just like she told me. Make sense? I used the definition. Now I gotta solve that, but that's the definition. And also I sort of did my graphing here to show you where this came from. Guys, to solve this, I would suggest to solve for x, let's subtract 5 from all these parts and end up with a negative 12 is less than these, drop out 2x. Less than 2. Step back and look at it. Divide by 2, so notice that 2 is positive. Those symbols are going to reverse on me. You make a mistake here. This is negative 6 is less than x less than 1. Yes or no? Now can you tell me what that might look like in interval notation? If x is caught between negative 6 and 1, if I say now place it like in interval notation like I did in my discussion over here, what might it look like? Negative 6, open, up to what? 1, and close it with parentheses. There it is in interval notation, say the same thing. Yeah, when these math textbooks, and I know students by now, I was a student one time myself. You think I actually sat down and read these math textbooks when I first started my program in math? No. I didn't know what they were saying. I relied on the professor who came in and translated for me. I didn't know what it meant. So I'm hoping this sketch sort of helps. Yes?
Never mind.
You got it? You got it?
Yeah.
Okay, okay. Now, the next one, we'll try just maybe another one here, maybe it's 2 or 3 of these. My second one looks like, here we go, this one, on the side. Put your hand out. Absolute value, 2 subtract 3x is greater than or equal to 1. So there's absolute value bars around it. Guys, which of the 2 that she read to us, there's only 2 definitions here. Should I try to apply this again, like I did on the last problem, or does it look more like an application of this one? Yeah, the second one. Now I gotta be careful. It looks like it might be the second one to be used here. Be very careful. Can someone tell me, what does this mean?
Maybe negative 3 is -1.
Okay, let's use this right here. U is less than negative A. What does that look like in my case? 2 minus 3x, that's the U, is less than, in this case, less than what, equal to? -1. That's exactly what she gave us over here. Is that true, guys? Now it says or, oh, there's another one here. Now can someone tell me, based on what was given to us, what does this part look like? U is greater than A. In this case, that U is what, 2 subtract 3x? Is greater than or equal to, I threw it in the equals mark. What was it, 1?
Yeah.
That was 1. I'll give you partial credit for showing me that much. Now all this will be on the quiz next week. Now you gotta solve each one of those. Guys, if I solve this one and I'm careful, this is negative 3x. It's less or equal to, looks like a negative 3, divide by negative 3, reverse. Please tell me, is it that? I did it real quickly. Is it that?
Yes.
I had to reverse my symbol. And it says or, like union. Now I gotta solve this one. Well, this is negative 3x greater than or equal to, looks like a negative 1. Divide by negative 3, x is less than or equal to 1/3, yes or no? Don't let me make a mistake. I did reverse my symbol. Is that true? That's the answer. Now tell me in interval notation. This thing has 2 parts to it. Can anyone tell me in interval notation, x is greater than or equal to 1 looks like what? Bracket, 1 through what? Infinity. Union, how about the x is less than or equal to, if we have no mistake, 1/3. What does that look like in interval notation? Negative infinity, up to 1/3 bracket. And there's your answer. Is that making sense? But you gotta know your definitions. And your definitions came from that sketch. Yes?
When we're answering a question like this, are you okay if we have them out of order and such?
Oh, absolutely. Oh, Shane, you mean maybe you put this one first?
Yeah,
Absolutely.
just one thing.
Absolutely. Not ordered. Making sense? Can't go wrong, but you gotta know those definitions. Now, it looks like I'm gonna do one more little item with you. You guys could try the others. Ah, boy. Am I ready? Yeah, I am ready. Here goes. Now, this was a little bit tougher. And I'm sure some of my students would love to be excused from the quiz tonight. Just go ahead and get your 10 points and walk out. Is that true? Okay. I need some help on this last one I'm gonna do here. Guys, the last one from that handout, I'm gonna choose this one. It's on your handout. Looks like this. Solve absolute value 1 subtract 4x plus 7 is less than 2. That means letter E on your handout, if I copied it down correctly, which I think I did. I gotta solve that. So, well, Professor, you're gonna use one of those definitions, I guess. Does anyone have a suggestion on this, my last one? I'm gonna work in class. To get me started. Shane, get me started.
Isolate the absolute value.
Okay, let's move that 7 over or subtract it. She says, Professor, do this. Marker 1, subtract 4x. Less than, I think if you subtract 7 or move that 7 over, do you get negative 5? Now, it looks like, can someone tell me, Isabella read this for us, can anyone tell us which case should I use? The first one? Okay, let's go to the first one and take a few seconds, guys, and I'm going to show you what it looks like. Take a few seconds. That'll help you out. Students are going to use the first. Looks like you should be applying the first definition. Okay, stop. Anyone have the answer? There is no answer. Shame on you. Got you on that one. I would think as a student, wait, Professor, don't set me up like this. I was sort of following it first. It looks like I should apply definition number 1 that she read to us. And this one, something strange happened. There is no answer. Can someone tell me why is there no answer? Go for it.
Is it because absolute value can't be less than negative?
How on earth could you, after you take the absolute value, which is going to be a positive for most of us, or 0, is there any positive number out there, or 0, less than negative 5? Can you give me something I can do here and replace x by it and come out with some number that, or it comes out on the left-hand side with something less than negative 5? It's impossible. So everyone's going to be taking the quiz. No one said no solution. Impossible. Is that true? Now, before I leave it, suppose it had looked like this. That one's done. Absolute value 1 subtract 4x is this. Turn the inequality symbol around. Another problem. Think about it. What's the answer now?
Real number.
Everything works. You may replace x by any number you wish. Because when you take the absolute value, are you guaranteed on the left-hand side after you take the absolute value, that left-hand side is going to be either positive or 0. And are all positives and 0, are they all greater than negative 5? This is all real numbers. One had no solution, the other one has all reals. Everything works. Okay, guys, let me check and see. Oh, that's beautiful. I think we've done enough. There's some other exercises there. But I think I've done enough for you guys to get an idea. True? Because I'm anxious to get into chapter 3. Anything to ask about here? I do wish your textbook had done something like this. I don't think they did. Something like this in terms of sketching to get to those rules to follow. Okay, stop here. Now, I have in my notes, besides that handout you guys have staring at you, something I gotta do and get this chapter 3 really started for us. And that is this. Oh, here we go. Yeah. There's something in my notes here I better point out right now before I leave. Absolute value. Guys, let me just start this as starting over. Part 1, let's want some input from you. Part 1, I have a function that looks like this. F of x is equal to, yes, this. Now we'll do some briefly, because my calc colleagues who are teaching calculus, math 7 are saying there are students coming in, they're saying, Professor, there's something about absolute value they're not quite getting that I need for them to work out a problem. Okay, let's see what it is. We all know that. That's what it looks like. Now, does anyone recall what did this look like? And I did this in this class. What does this look like as a piecewise function? Here I am tying math together. I'm going back to a piecewise function. Can you rewrite absolute value of x, that V-shaped graph I was just discussing, but write it as a piecewise function? Does anyone recall what it looked like? Go for it.
If x
Equals what was the first bit? We've got two pieces.
if x less than 0,
Negative x,
negative x.
negative x, if
Yeah.
x is less than 0.
Yeah.
Okay, and tell me the other piece.
And x.
X, if,
X is.
and I think you pick up the equal to here maybe.
Yeah.
You guys remember me showing you this way back? That's like a definition for absolute value. Now it's written as a piecewise function. Now I'll tell you what my colleagues are telling me. That's why I changed my notes here. They're saying, Mr. Park, Eugene, I bet you guys can relate to this. There's absolute value. You have it in your notes. Now underneath here, all of a sudden there's a calc problem that comes up, and I'm supposed to get you ready for calculus, and it looks like this. I'll make it simple. Now watch carefully, because this is probably the only thing I'll do on this. I'd like to write this one, because my calc colleagues are saying, we asked them to do something on this, and they were all confused because that absolute value, those absolute value bars, they got confused. We need to rewrite that. Now, can anyone help me, based on what we just did earlier, what might this one look like as a piecewise function, two pieces, which will make the calculus much easier to do? Now watch carefully. He's already given me the basic definition. Look at it. What might this one look like?
Negative x plus 5.
Okay, hang on. Negative what now? X plus 5?
Mm-hmm.
If what?
X is less than.
He gave me x is less than 0. In this case, what? X plus 5 is less than 0. Is it true? By the way, let me put in parentheses right here next to it. This is the same as saying x is less than negative 5. You guys agree? Now, the definition says this for the second piece. What would this one look like? Absolute value of x plus 5 for the second piece would be x plus 5. That's x. That's what they're considering the x. If what? If x plus 5 is greater or equal to, here we go, 0, which really means this. X is greater or equal to negative 5. Is that true? Now you have this broken down into two pieces. And your calculus is going to be much easier to deal with on these two linear pieces than this. So that's why they're going to ask you to break it down. First, you guys agree with this? Looks pretty good? Now, to close it down, this is all I want to say here. To close this down, I'd like to, with your help, ooh, yes I would. I'd like to graph this and get a response, and then I'm finished with this. Now, you had an exam not too long ago, and you had to graph a piecewise function for me. And many students got it correct. I think it's on that last exam, wasn't it? Didn't you have to graph a piecewise function on that last exam? I just returned to you. Yeah, you did. Now I've got a piecewise function here. I'd like to graph this one. So guys, many students are saying, Professor, I like this business. Like you showed us, to be careful, I did a table. I'll do this one in blue, and the other one here in red. Like you guys did on the last one. Now this says restriction, x is less than -5. Let's start with -5 though, to see what happens. -5 right here, and let's try something less than -5, like a -6. That might be enough in that table. The red one says you can try anything greater than or equal to a -5. So I'm gonna try a -5, since I see it first. Something greater than -5, guys, what do you wanna try, -4? It's up to you. Yes or no? You can try other numbers. Let's go back to the blue. If you go back and put in -5, where am I? Help me out here. Where am I anyway? 0, you go 0. Now. And that's going to be an ordered pair. If you put in -6, guys, what are you going to get? I think it's what, 1? I think, was it 1 or -1? It's 1, isn't it? You put in right there. The red one, -5, of course, right here. It's going to give you a 0 again. We did these piecewise functions before. Put in a -4, I get a 1, do I? I think. How do you plot those? That's what we did. Now we'll plot the first one. It says go out to a -5 in the blue. -5. Why not make all this math connect for us? This is -5. I notice on this one it was not supposed to be included. Don't place it open. And then I try to point -6 up 1. Extend this out. And it looks like this. -6 up 1, the same one's right there. Just look it quickly here. There's a point right there. Now I think that's enough to say, Professor, you're talking about a shape, a linear, that might look like, please don't line up for me, that might look something like that. Did you guys agree with the table? The red one says now go down to, I have a -5, 0 again. I think this time I'm allowed to use, in the red, -5, 0. I do, right here. I get to close this in. And then I tried what, -4 up 1? So if I go -4 up 1, please guys, would I be somewhere in here? On the red one. Is that true? Is that enough now? 2 points to determine the line? Is that enough now to connect and say, Professor, the other piece is, well, it looks something like this. Yes or no? And that's the graph of the absolute value that I was dealing with up here. Now, I did in pieces. Okay, here's a connection. Suppose you didn't do it in pieces. You didn't write this as a piecewise function, which you may have to in calculus. And your instructor says sketch it. And you did not do this. Tell me quickly, how would you sketch this based on what we've done in class?
Shift left 5.
You horizontally shift the V-shaped graph, what, 5 to the left? Is that what happened here? There was a transformation. The graph's been shifted 5 to the left, except we did it in pieces. So we could express this thing as a piecewise function, if I had to. Okay, part 2, I had to do that. Now, here we go. What on earth is this? Finally, a polynomial function. Now, before I jump into it and describe it for you, and I gave you a definition, I think, on the handout. So we'll take a look and see what the definition might mean. Guys, before I jump into it, let me think. They love the word function for this class. I just did absolute value function that was attached to that. Quadratic function. Help me out. What else have we used in class where we attached the word function? Think of something else we've done in class that we had function attached to it.
Even or odd.
Here we go.
Even or odd.
The even odd functions. I heard the
Step function.
step function, the int function. What else? Do you recall anything else that we had the word function attached to it? Quadratic, I think I mentioned quadratic, right? Tell me again.
The like library of functions?
Yeah, we had the library of functions. Did we not have a cubic function, a cube, on that handout? all that's on that handout. Quite a few, right? Absolute value and so forth. Now, they give you another function. Oh, Professor, how many functions are there? Oh, wait. You're not going to ever see all of them. These are going to be the basic ones. Next one's a polynomial function. Now, before I jump in and show you from that definition what it looks like, let's go back to middle school. We need to make a field trip. Go back to middle school and see what they're doing over there. Anyone tell me, way back in your math somewhere, your teacher probably discussed probably 3 so-called polynomial functions. They were given special names. But they were actually all polynomial functions, but they were given special names. Can anyone recall a special polynomial function, a special vocabulary word from middle school that might be applied here? There again. Binomial. Binomial, you have what? 2 terms? And? Trinomial. 3 terms. And the other one that most teachers back in the middle school would discuss is the one that has only 1 term. Monomial. So you had monomial. And here's the word. I heard binomial. Absolutely. I heard trinomial. Now, I doubt that they ever discussed one with 4 terms. They may have shown you one, but I don't think they may have given a name to it. There's a name to it. 5 terms, 6 terms, and these terms can go forever. So the 3 basic ones are these that you saw back in middle school. Now, what do they all take the form of, though? That's where I need now a student to read for me. And I know it's going to look strange, and I'll help you out as I write this. The definition on the handout for a polynomial function. Shane, go for it.
P of x is equal to a subscript n.
Thanks, all right there. A subscript n. Go for it.
X
X.
to the power of n.
Okay.
Plus a subscript n minus 1 x. Oh yeah.
Raised to?
Yeah.
Raised to n minus 1?
Mm-hmm.
Okay. Did I write another one out for you also?
Yeah.
Did I write a subscript n minus 2? Did I do that? Okay. Right next to it, probably x raised to the what? N minus 2? And then this thing continues, I'll probably put plus, and it goes like that for a few terms, and it finally ends. Did I have it to end somewhere?
You said a subscript 1 x.
Okay, beautiful. I didn't throw in a subscript 1, x, then plus what on the end?
A subscript 0.
Look at that. Now you talk about frustrated. You guys have not experienced frustration yet. You haven't experienced frustration. You go to grad school, and what you see is this. And all that professor does, he starts out with this. He doesn't discuss monomial, middle school, binomial, elementary school, trinomial, kindergarten. No. He or she jumps right into this, writes it on the board and say, here it is. And y'all say, what is that? It's a polynomial function. They're telling me they take that form. Now, Shane, when you read this to me, I'm going to go through, I don't know whether I identified some of the parts of this or not. Did I? Okay. Guys, this a subscript n is known as the leading coefficient. The leading coefficient. Let's see if I spell that coefficient right. Leading coefficient. So it's going to be more than likely a number stuck up front. A 2, a -3, 1. Whatever it is, it's called the leading coefficient. I noticed that when she read this to me, she started me out with x raised to n. And that's my largest exponent in that polynomial function. It's going to tell me what the degree is. So guys, the degree will be the highest exponent. They identify it with an n. Now, notice from middle school, most teachers, when they teach this, in what they do with this in middle school, is they ask the students, please write the next one as n minus 1 for an exponent, and the next one n minus 2. They usually ask you to put this in descending order. You may start out with an x cubed, then your teacher probably said, please put x squared next, and then x. Or x to the fourth, x cubed, x squared, x. They usually ask for it in descending order. That's what she read to me. Start with n, drop it down, n minus 1, drop it down, n minus 2, until finally it's gone. Now what's gone? The x. So when you finally reach the end, there's no x. They call it a subscript 0. This might represent just a constant, a number, no x with it. So leading coefficient, degree, I have it in descending order, and I got a constant hanging out on the end. So that's what polynomial functions look like when you write one out. Now, we have quite much to do with those polynomial functions, but let me do this. On the side here, let's write p of x. Now let's make up one real quickly standing here. Looks like this. That's a polynomial function. And the one I made up real quickly has 1, 2, 3, 4, 5 terms. What's the degree on this one? 4. Did I place it in descending order? I put 4, 3, 2, 1 with the exponents in descending order. My leading coefficient is -3. My constant on the end is -6. Those are going to play a big part with what's coming up. Big part of what's coming up here. Let me think right quickly. Yeah, I'm going to think about it. That degree is 4. Guess what that tells us when we start our work? Besides being degree, a name associated with it is called degree 4. One more that 4 indicates must happen soon. Shane?
How many zeros?
How many zeros? You got to find 4 zeros. If there's a 10 up there, you got to find 10 zeros. Now you say, Professor, not 10 zeros, please. You mean, Professor, if you give me this, just that, that's a monomial. That's one term. They classify it as a polynomial. One term, x to the 10th. The degree is 10. I'm supposed to get 10 zeros. 10 answers. What are they? 0, 0, 0, 0, 10 zeros. So you can have multiple answers. They repeat. So you could show that there are 10 here. The first one would have to give you 4 zeros. Now that said, I've got to watch my time here. Oh boy, do I really have to watch my time here. Here we go. On the side here, there's the definition, part 3. By the way, guys, are these handouts helping? Yeah. As I bring those in, I hope so. For goodness sakes. Here goes. Now I'm going to jump right into it. Zeros of a polynomial function. At the end of the page. It says here, find a polynomial function whose real zeros are given. They're going to give the zeros to me. I don't have to find them. So in the next part here, guys, the first one, and I'm going to look at these carefully, they write down the work for me. They're saying the zeros are these. When I solve, and they gave -5, 0, 6. And they want a degree 3. polynomial. And they're saying that should be enough for any student to write the polynomial that those zeros came from. Now, can someone in this clever class that I've been bragging on, some of those other math professors are waiting for you. Anyone tell me what polynomial function would give those 3 zeros? Anyone? So I hang on. Yes? Ella.
Parentheses,
Tell me again?
parentheses,
Okay, parentheses.
x plus 5,
Love it.
parentheses, x minus 6.
She said, Professor, please. It's that. It's that. If you go through and split those up like we've been doing in class, would you get those 3 zeros they listed for me? Of course you would. Now, more than likely, the textbook would probably say expand that out. They probably would say multiply it out. I'm going to do it real quickly on this one. Bella, with what you gave me, I think I'm going to put that x first. I think it would be better placed out front. She gave me this, which I agree 100% with. Now, if I want to multiply this out, guys, here it goes. I'm going to do it quickly. I'm going to leave that x where it is. I'm going to multiply these two together first. Expand it. Some students call it FOIL. You're going to end up with x squared, I think, subtract x, subtract 30, yes or no? I did it quickly. Then use the distributive property. Distribute x, you're going to end up with x cubed, subtract x squared, subtract 30x. By the way, does that have degree 3? Is that the highest exponent? That's what they wanted. They wanted degree 3. Now they're saying that x cubed subtract x squared subtract 30x has these zeros. You guys agree? I didn't make a mistake, did I?
No.
Okay. Yes.
How to know the reading coefficient is?
Not beautiful? Beautiful. He said, that was coming up next. He said, Professor, I noticed you mentioned, where was it? Yeah, right here. A subscript in the leading coefficient, they call it. And Professor write down it for me. Guys, what do you think is understood to be on this one? The leading coefficient. 1. It's not written, but it's understood to be a 1. Well, I'm glad you brought that up. 1 x cubed out front. And that's my trinomial. This one has 3 terms. Polynomial function. Now that's said, part E on the handout. But I do bring these handouts in. I could never get all this done. Oh my goodness, the next one's a beauty. The zeros are these. -2, 0, 1, 3. They want a degree 4. Oh, they add something to this. And the graph, we're not going to graph it, but the graph contains the point. I'll just put it right here, guys. -1/2. Huge number. -63. Step back and look at it, make sure I jot down all the information. Beautiful. You're going to write the polynomial function that satisfies all that. Here goes. Shane, you helped me last time. Get me started again. With what they gave you for those 4 zeros, tell the students what the factors would be to form this function. This one would be what?
That would be x plus 2.
Plus 2. Okay. And let me bring it down here. Okay, tell me more.
X
X.
minus 1.
Beautiful.
X minus 3.
Look at that. Now, I'm not going to multiply this one out. We could. Does everyone see, though, if I should multiply it out, even right now at this point, would the first term be an x to the 4th?
Yes.
And that's what they wanted. They want the degree to be 4. Except I'm not going to expand this thing out. But they did something else. They said, don't stop there. I'll give you partial credit. They gave me a point that belongs to that function. In other words, it's on this graph. It belongs to it. So what could I do, besides what we've already done already, to go further? And I replace x by, they said x is what, negative 1/2? And over here, this p of x is like y, negative 63. And guess what I'd be solving for? I'm so glad he brought this up. Now I'm going to replace all that, definitely. But Professor, what are you going to be solving for? This one's going to actually give me, what did I identify this with an A over here? A subscript N. This says, with the question he had earlier, I am now going to try to find that leading coefficient. The A subscript N, they call it. So you guys just plug this in, and I'm going to make it fairly simple here. P of x is negative 63, given to me. I'll just call it A, guys. A, x plus 2 would be a negative 1/2 plus 2. Negative 1/2 for the x. That's this one. X minus 1, negative 1/2 subtract 1. No problem. And negative 1/2 subtract 3. Did I put those in correctly? Whew. Okay, negative 63. I can do some math here. Negative 63. We have A. Now, in the first set of parentheses, guys, we use a common denominator of 2. Negative 1/2 plus 2, what is that, 3/2? Just doing arithmetic. Of course, this is negative 1/2. This is a negative 3/2. We could all do this. And I think this is a negative, help me out, 7/2? Don't let me make a mistake. Is it negative 7/2? Okay. And you try to solve for that leading coefficient, the A, I'm calling it. This is just algebra now. This is negative 63 is equal to, now, if I multiply all those together, it's going to be over 16. 2 times 2 times 2 times 2. Is that true? 16 for my denominator. What an interesting problem. On top, I see a negative 3, positive 9. Is it negative 63? I did it quickly.
Yep.
Negative 63. Jeez. And that's A, out front. Ramsey, why'd you bring this problem in? It looks crazy. I gotta solve for A. If you go back to algebra to solve for A here, guys, give me a suggestion to sort of close this down. How would you solve for A? If everything's correct.
Multiply by 16.
I'd multiply both sides by 16. Now, I'm not going to multiply 63 times 16. You could. I don't think you need to in this case. But it looks like this. Negative 63 is being multiplied by 16. The thing was, a student said, Professor, just go ahead and multiply both sides by 16. If I multiply this side by 16, well, the 16's cancel. Leaving me what? Negative 63a? Yes or no? Is that true? So there's no need to multiply 63 times 16, because now if I divide through by negative 63, and make no mistake, and I hope we don't have a mistake, will these cancel? Yes or no? And then we'll end up with, at this point, what is that? 16? These cancel, of course. Is that it? A is equal to 16? After all that effort? Final answer? P of x, if there's no mistake, 16. I would not ask you to multiply this mess out. Leave it like it is. And there's your final answer. Wow. I see some students glancing at the clock there. My goodness. Got 4 minutes. I'm going to use my 4 minutes. Guys, does that make sense? The one we just did? Okay. Let me check on the handout and see if I do need to do anything else before we take a break here. Oh, I do, guys. Hang on. The last one. Now, you have it on the handout. So save me a little bit of time. I'll have a student read it to me, and we'll just put it together for you. and not write out everything on the board, because we have it on the handout here. I'll close this down. Alexandra, if you're close by, would you read that last one there where they asked me to do the same thing? Write the function and tell the class what they gave you.
Number 3,
I think it's the last one on the handout, at the bottom there. 0.
-5,
Mhm.
multiplicity 2,
Hold on. I was abbreviated. Multiplicity of 2. What do you think that means?
It's squared minus
It
5.
repeats. It's a multiple answer. So it's -5, -5. What's next?
2, multiplicity 1,
Oh, wow. Okay. You're getting a little fancy on this. Multiplicity 1, if they want to say it like that, means it's 2. Just one time. What's next?
4, multiplicity 1,
Hang on. Okay.
and contains the point 3, 128.
Oh, my goodness. Here it goes. 3, 128. And then we're gonna take a break, guys. You'll need a break. Okay, they're saying, please write the polynomial function that will give me, satisfy all of this. Now, be careful. I got -5, -5. Anyone tell me a good way to express that to show that's what I should get? Isabella? What do you think it is? This part right here. Oh, there can be a square in there. What'd you say though?
X plus 5
It is. %. This says -5, -5, doesn't it? Next, we got that one out of the way with her help. Now 2, just one time, I'll do that one. That's X subtract 2. That's out of the way. This one down here, 4, also what? Multiplicity of 1? X subtract 4? Look at that. That's written out. But they gave me some added information, which means now they're giving me enough information to close this down to find that A, the leading coefficient. So guys, here we go. 128 here. A is missing. In place of X, put a 3, please. Just be patient. And I'm hoping I'll have enough here to solve for A. We got 128. With an A. Guys, what is that, 64? Oh boy. 3 subtract 2, I can do that, definitely 1. And down here, -1. Comes out to be what, 128? Is equal to, guys, all this right here is -64. Oh yeah, this is much better. And then divide both sides by -64. A is -2, isn't it? Therefore, you go back and say, Professor, now write your answer as P of X. The leading coefficient, -2. Of course, everything else stays like it is. And we are finished. There's my polynomial function. Is that making sense for us? Oh. All right, you guys, we got 10 minutes to take a break. 10 minutes.